Hi, ladies and gentlemen. This is Mr. Green. This is another in my series of recordings for geometry. And today we're going to be taking up the concept of in lessons 1.07 and 1.08, which are dealing with prisms. Okay, so don't forget, make your quiz corrections. It helps you stay on top. There were several people last semester that passed because they kept making all the corrections and everything they did. It helps you rework the problems. It helps you feel better about getting things done. Don't let things go beyond 28 days because then they will be past due and they will get closed and you will not be able to get them done. So you want to make certain you get them done before that time frame. Moving forward, prisms. What is a prism? A prism is an object that has at one end some geometric shape, like a square or a rectangle or a triangle or something like that. It is connected with a height because the prism has bases that will be the same shape and is connected by some height, h. Now I realize that height is not going up, but is the distance between the base, this base and the base back here in the back that you can't really see. Okay? That is the way prisms are put together and the way we're going to refer to prisms. Now, when we're referring to prisms, there's a couple of things that you need to be aware of. First of all, prisms can have, you have to figure out the area on the outside of the prism that covers the entire thing. What is that? It's the wrapping paper around the box. It is the anything that you consider on the outside, or it's the paint that would cover the complete object. That would be the area, surface area. Okay, and then there's the space the prism takes up, the air on the inside of it. That would be the volume. These are the two concepts we're going to cover in here. Okay, so when you look at a prism, anytime two lines come together, that is called a vertex. That's called an intersection of two line segments. It's a vertex. Okay, and there's vertexes all the way around a prism. There's the same number of vertexes on the top and on the bottom. Bases. The top and the bottom that are considered to be the same are considered to be the bases. Okay? The lateral face. A face is some edge, is some area here. So this would be a face right here. Lateral meaning it's connecting the two bases together. That would be a face. An edge would be this thing right here. It is the line that connects the two together, or an edge up here would be one that connects two vertexes together. Those are the parts of a prism that we're going to refer to. Okay? So when we're looking at the space of a diagonal takes up, or the space and, face and space diagonals, the difference there. A diagonal that is on a face of an object here, connecting B and C, that would be a face diagonal. Now the way you would find that would be using the Pythagorean theorem, or the distance formula between 2 points, between B and C. A space diagonal, one that's going from A to C here, is not on any particular face. So what do you have to do to find it? You have to find the face diagonal going down this way, and then you can use this edge over here and this space diagonal, or the face diagonal here, and you use those two numbers in the Pythagorean theorem to find this distance of the space diagonal. It's the way those are put together. So there is a formula for the space diagonal too. We actually consider all three dimensions, the height, the width, and the depth. And we're going to use the square root of the length plus the square root of the length squared plus the square root plus the width squared plus the height squared. You take all those together and it gives you the distance of that space diagonal. Okay? Here's an example of how we would work that type of a problem. If this prism here has a height of 10, a length of 8, and a width of 6, you come in and you stick those values in for height, width, and length, and you got 8 squared plus 6 squared plus 10 squared, 64 plus 36 plus 100. It's 200. Square root of 200 is 14. This unit right here, 14.14. That's how that distance is measured. Okay? Now this distance right here is going to be 10. How come? Because 64 plus 36 is 100. Square root of 100 is 10. That would be this distance right here, 10. It's easy to use these type of problems and work these type of problems. Surface area, on the other hand, is the wrapping on the outside of the package. So that means finding the area of each one of the different sides. This formula right here says 2 times the base. That's the area of the base, the two things that are the same, this green area, this one on top, plus the lateral surface area. Okay? Well, how do we find the lateral surface areas? Well, we can actually just figure each one of them as the types of shapes they are. They're rectangles. You have to know the height and the length of each one of them. You figure each one of them and add them up. Okay? So here's an example. I've got a triangular prism. Yep, we can have triangles here. So let's see if we can't find this one. The area of a triangle. Well, we're going to use the formula for area of a triangle, 1/2 the base times the height. And in this case, if we use our base to be 3 and 4, and that'd make this one 3, and it would make this one 4. We would take 1/2 of 3 times 4, or 6 would be our base. Now, what is our height? If we say that our height is 9 in this situation, we would take, to find the lateral surface area, we would say 9 times 3 plus 9 times 4 plus 9 times 5. Where'd the 5 come from, Mr. Green? Well, I used the Pythagorean theorem real quickly in my head and realized that that is 5. That side there is 5. That makes this one 5. That makes this one 4. Makes this height here is all 9s all the way going across. Do you see how I laid this out in this net to find the surface area? And then just use the fact that I could divide it up into these different size areas to find the area of each one of them. So 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and we would add those three numbers together, and we get 11 and 7 is 18, carry your 1. That's 8, 10, 108. That's the lateral surface area. My base was 6, so my total surface area is going to be 2 times 6 plus 108. That's 120. That would be the surface area. Remember, these are square units because it is area. Okay? So to find the volume, you take the area of the base and multiply it times the height. Simple formula, base times height. Okay? Here we've got a trapezoidal prism. Trapezoids on both the bases. That means I need to find the area of the base because we're wanting to find the volume. It means I got to find the area of a trapezoid. That's 1/2 base 1 plus base 2 times the height of the trapezoid. Well, the height of the trapezoid is that 5 right there. My bases are 19 and 15. So when I add those together, multiply times 5, divide by 2, I get 85. So I take that 85, I multiply it times the height of the prism, 15 feet, and that gives me this 1,275 feet cubed. Because it's to the third power. We're multiplying things together, and it puts it to the third power. So I've shown you how to work several problems here, doing surface area, volume, and doing a little explaining a space diagonal and a face diagonal, and making certain you understand how those work. I will be working more problems in the Class Connect, and I look forward to seeing you there. Okay? Thank you very much. Talk to you then.